So, welcome everybody to this session about open systematic reviews. This is a presentation that evolved from an earlier presentation that's about a specific software that I developed for this purpose called MetaBefore, which focuses on doing systematic reviews in a way that are modular, extensible, transparent, accessible, and open. For this presentation, I'll discuss a few bits of that approach, but mostly the focus will be on how to do a systematic review completely open. So that means transparently, but also with open science infrastructure. So that means that you don't use, for example, Medline or PsycInfo, but instead you use one specific bibliographic database that's called OpenAlex. Systematic reviews basically came out of the observation that people started doing reviews as the scientific literature grew, basically to summarize the findings that had come before. And it's quite easy, of course, for bias to seep into those results. And therefore, people sought for ways to make the process more and more systematic. So in the old days, you could kind of get away with narrative reviews. In the present days, you can still get away with those if you are super established in the field, because then you'll probably be able to publish it somewhere. But otherwise, editors and reviewers will tend to point out that if there's no transparency as to your process and how you obtain the sources that you want to synthesize in your literature review, well, it's not real science. It's basically your opinion. So systematic reviews are literature reviews where the process is as systematic and transparent as possible, so that you, in advance, while you plan, already explicitly take the decisions and ideally justify the decisions that determine which sources you will include, how you will extract stuff from those sources, and how you will draw conclusions based on the stuff you extracted. A specific type of systematic review is a meta-analysis. That's also a name for a statistical analysis. And that statistical analysis allows you to aggregate multiple estimates of means or percentages or effect sizes such as correlations or coherencies from multiple different studies or multiple samples in one study to one more accurate estimate. So if you have a certain medicine, for example, and you have a lot of randomized controlled trials, RCTs, basically experiments with two conditions, and one condition gets a placebo, the other condition gets the medication, and you have 12 studies that studied this medication, then by meta-analyzing those results, you can get a better estimate as to the effectiveness of the medication, as well as some insight into how differences between the studies might also be associated to differences in that effectiveness. A type of systematic review that's becoming more popular in recent days is the so-called scoping review or evidence map. This started out as a way to basically map the literature, so you don't actually look at the kinds of research questions that researchers studied. Instead, you just look at the kind of designs they used, or the kind of measurement instruments they use, or other kinds of decisions they take. So that once you finish your scoping review, you have an overview of how the literature looks, and you can see which topics have not been studied so much, which kinds of designs tend to be used a lot, and which kinds of designs are perhaps underused, which of course is great if you want to start new research somewhere. You kind of know, you have a map of the niches to fill, so to speak. And this approach is used more and more now as well to answer other kind of meta-scientific questions. So the distinction that I use is that a systematic review or meta-analysis tends to basically provide a better answer to the same kinds of questions studied in the primary studies that are included. And a scoping review or evidence map answers different kinds of questions, often about how things are studied or which things are studied. So more meta-scientific. So systematic reviews, to those who are not yet familiar with them, I added some basic explanations, have 4 stages. The first one is that you search for stuff in a bibliographic database. So some proprietary ones, so closed science ones, are PsycInfo, PubMed, ERIC, GreenFile. So the most familiar ones you'll find in our university library. And OpenAlex is a relatively new one that is completely open. You can basically download the entire database if you want. They place a dump, so a complete download of the database, on their server once a month, I think. And then you can download all 12 terabytes or however large it is. So those are the bibliographic databases, and they contain titles and abstracts of journal articles. So you can use those to find articles about a certain topic. Then, if you enter a query in such a database, you usually get way more articles than you actually want. Both because you generally don't want thousands, but also because you will get false positives. You'll get articles that use the same types of words, but don't study the thing that you're interested in. So the second phase is screening, where you actually select the relevant hits. The third phase, once you know these relevant hits, which are many, many fewer usually than the number of hits you have from the bibliographic database, is that you extract the things in those sources that you're interested in. So that can be an effect size, a mean, information about a measurement instrument, information about the population they studied, anything really. Once you have this, then you can do the analysis, the synthesis. And this can be a meta-analysis, or it can be more qualitative. You can do lots of things, but that's the last step. And just like with other research, the planning goes the other way around. So you start the planning by thinking about your epistemic aims, the kind of thing you want to find out about in the world, the research questions you have. And based on that, you know which analyses you'll want to do. These analyses are called syntheses in systematic review land for some reason. So which analyses or syntheses you want to do. And when you know which analyses you want to do, then of course you know what you will need to do those analyses. So you know what you will need to extract from the articles you want to study. So that means you will have to define those things to extract. That's quite hard, so I'll have some more slides about that to explain it a bit more in a second. And once you have clarity on what you want to get from those papers, then you know how to screen papers for presence of those things that you want. So then you can define your exclusion criteria on the basis of which you exclude papers during the screening. I call it exclusion criteria. Often in literature, they also talk about inclusion criteria, but actually the inclusion criteria are in your bibliographic query. During the screening, if you have an exclusion criterion that is, for example, that the subject has to be humans instead of animals, and another criterion is that the study has to have an experimental design instead of another type of design, then of course both have to be true. The study has to study humans and has to be an experiment for you to include it. None of these can actually be used to include the study. If the first exclusion criteria leads to exclusion, then it doesn't matter what happens with the second criterion. Even if it would lead to inclusion, you would still exclude it, because if the study has an experimental design but it's not about humans, it will still be excluded. So effectively, during the screening, what you try to do is to exclude as many papers as possible, provided that you are sure that the exclusions are not interested to you. So once you know what to screen for, then you formulate your query, which basically tries to find all the articles that you're interested in that you will then include in your screening, that you will extract data from in the extraction, and that you will then analyze in the synthesis. So these are the kinds of questions that you actually ask in the order from left to right. So you start with the analyses, then you think about the entities you want to extract, then you think about when you can exclude sources, and then you think about the inclusion criteria. What are you looking for in the bibliographic databases? Because the extraction is the most complicated thing, and also basically one of the first things you do. I'll explain that a bit more in detail. So an entity is anything you extract from a paper. So for example, characteristics of the target population, study design, the constructs that people study, and target population characteristics. You might want to subdivide into age, sex, maybe gender. Study design, you might want to look at the time between different measurements or the covariates that are included. And if you look at the kind of constructs that people study, like for example, the feeling of safety that people have, or the level of literacy, or the degree to which people use green spaces outside, whatever, then you have to choose whether you extract those in the author's own words, or you recode those concepts that people study into your own definitions so that you are sure that it's consistent with how you define things. But if the definitions in the literature are not sufficient for coding, which is quite often the case, then you first have to develop this set of definitions yourself, but it might be quite a lot of work, or code in the author's own words after all. And then if you extract in the author's own words, then you can code it like qualitative data afterwards. And the same question you can ask about other things like gender. Gender can be defined differently in different cultures and in different regions. So there also, you might want to not just use the words authors use, but make sure that actually, when you extract something in a certain way, it fits with how you define it, rather than how they happen to define it. So the most important question in the beginning, once you know which analysis you want to do, is what you want to extract and how you're going to extract it. Whether you have some categories that you can use already, which means that you can't find stuff that doesn't fit in the categories, of course, or whether you want to be completely open. And then you usually extract just the literal text that authors use, and you code it later as qualitative data. I'll have an example of that later. A lot of the stuff I explain, I'm trying to, when I have time, put down in text in this book. So you might want to look into it if you do want to do a systematic review, to basically slowly read up on this stuff. Okay, so once you define the entities you want to extract and how you define them, then you can start looking at the screening. And that basically boils down to the same thing. First, you define your exclusion criteria, and then you have your hits, all those bibliographic records, and you go through them one by one to decide whether they fit with your inclusion criteria. And it just so happens that a colleague of ours for the Verlicht project actually created an application to support this screening. It's called Sunscreen. I realize now that the URL is not here, but I can mail it around later if somebody wants to use it. Some of you already use it for a project. Basically, the idea is that you can upload the files to Screen. It gives your project a unique identifier, and then you can use that unique identifier to do the screening. And then it shows you the title and the abstract. This paper doesn't have an abstract, but this one does. It shows you the title and the abstract, and then the buttons with your exclusion criteria are included at the top. And as you saw here, the definition of the exclusion criteria, as well as the instruction for where to apply it, are included below the record. And because those buttons are always at the same place on your screen, you can quite efficiently go through the records, because you usually have to screen a lot of records. And quite often you can determine quite quickly, based on the title or the title and the abstract, whether it should be included or not. So this app is really optimized for doing this as quickly as possible. It also stores the reason why you exclude something, which you will need later on if you write the paper, to create the so-called Prisma flowchart, where you explain how many articles you excluded because of which reason. And then you can basically cycle through the hits, and it has an overview of which ones you did already, which ones you didn't. And the app keeps getting better and better. So if you want to do a systematic review and you do screening, contact Hessel Pullman at the Faculty of Sciences, potentially through Manon or me or somebody else. And then we can get you in touch and you can get running with this. Okay, then once you have all your data, as you notice, I'm postponing the actual search for the OpenAlex bit. Once you get your actual data, you can do the analyses. For the analysis, if you do a meta-analysis, Metaphor is one of the biggest packages for meta-analyses. That's an R package, and it has very extensive documentation. So it's basically what most people use for systematic reviews. There's also an entire, they call it the metaverse, set of R packages that can all help with different aspects of doing systematic reviews. So if you want to do a systematic review and you use R, these might also be worthwhile to check out. There are two that we work on here at the Open University. One is called Preregger, which is an R package that allows you to define your own pre-registration forms, but also to complete and store pre-registration forms. And MetaBefore, that's the one I showed earlier, which basically supports your extraction process. Did somebody open their microphone? No, then I misheard. Okay, so as I explained earlier, in the extraction, you can also extract literal texts, and then you can export those to study qualitatively. What you see here is a spreadsheet, basically a table specifying entities. Every row is an entity, and you see, for example, that here we extract stuff about the authors. On row 11, you see the definition of empathy, because in this study we are interested in how people define empathy in the literature. Then this is converted, that's what the MetaBefore package does. into a text file, basically. You see syntax coloring now provided by R, but it's basically just a plain text file. And you scroll to the text file and you export stuff, and then you can validate it to check whether you actually exported everything correctly. So you see here that population fails its validation because apparently there was no string, no letters, no characters added. And then you do this extraction for all these papers, and then it's imported into R, and then you can do the analysis. As I explained earlier, Meta-B4 was created to make these systematic reviews scalable and extensible. And this workflow lends itself very well to starting with a relatively superficial, efficient scoping review. And once you did that, you have an overview of the literature, and then you can only add the entities, the extra entities you're interested in for a few of the studies. For example, the experiments of the ones with your target population. And then you just add those and import those as well, and then it combines everything into one big database. So the system is kind of created to basically to make the literature machine readable, according to your definitions and your categorizations, of course, because ultimately science is subjective. So an example of how it would look if you extract literal text and then code it as qualitative data. There's this paper. You see the so-called short DOI at the top. That's a unique identifier for a paper. This is a study about resilience. And here you say they indeed have a relatively loose definition of this concept of resilience. Then you can extract it, and then it looks like this, the capacity to bounce back from a situation. And then that can be exported once you did all your extractions into a file that you can code. Here you can see the definition from the study again. You can see here, this is the same unique identifier, the short DOI or DOI of the article that it came from. This is the name of the entity in our dataset. And here we can see the two codes that this extractor or coder decided to attach to this definition. That can then be imported back. Okay, so that's the analysis. Now, all the way back to the beginning, the search. And as I explained earlier, this is mostly about doing an open science systematic review. So the focus is on OpenAlex, which is this completely open search engine. You can find it at openalex.org. And then you see this, basically just the search engine, and you can type in something. So let's imagine that we want to do a systematic review to see what we know about interventions into low literacy. As you notice, the list of synonyms is relatively short, but that's because I wanted it to fit in the search box. And then if you hit go, you see this. You basically see the list of included results on the left-hand side. You see some summary stuff on the right-hand side. And you see the button to download the results in the middle. I can actually show it. There is the button to download stuff. Because I've done presentations like this before, where I relied on being able to show whatever I wanted to show live, and it didn't work, I've now made screenshots. So I can't actually show you the download, but basically, trust me, you can download the stuff. In this case, 1460 hits might be too much, and we might actually only really be interested in articles that are about low literacy and intervention programs and don't kind of study them in passing. So what you can do, what I then often do as a low-hanging fruit, quick and dirty fix to find central articles, is to change where you search. And you can do that with this plus button here. And then you see a number of fields that are often used. But if you press more at the bottom, you can see even more fields. And then if you scroll down, you can also select just the title field. So then we enter our query in the title field. And then we can remove the title and abstract one. And then we only have 64 results. If you would want to answer any question quickly, this would be quite an efficient way to actually get a pretty good answer about what we know about low literacy programs if you need something quickly. Of course, it's possible that there are other terms that are used, but as long as those terms are not used consistently by research that is either much more effective or finds much higher effect sizes or much lower effect sizes, that's not really a problem if you want to get an impression of how effective it is, of course. It's not about finding everything necessarily. That is the case if you want to do a meta-analysis, of course. But in other cases, you don't necessarily need to have all the literature to answer a question. You just have to get an unbiased sample of the literature. One of the nice things about OpenAlex is that you can then click one of these works, as they call them, And then you can see some more details, as you see here. You can immediately see which articles it cites and which articles cite this article. And you can do that trick as well for the authors. So one of the cool things is, you probably all know Google Scholar, where you can create your own profile. OpenAlex has profiles about every author. You don't even have to create it. They just know that an author is a person. They have an ORCID, like a unique identifier, and they show all the works from this author. This person apparently has an insane age index of 90, so they're probably, hopefully, old, because your age index keeps increasing over time. Oh, they also publish like 1,000 works, so they're probably an AI. And this same trick you can also do for institutions. So this is apparently the institution page for the University of North Carolina at Chapel Hill. That also means, of course, that the Open University is there. So if in the search box on the OpenAlex homepage you type the Open University, you find us. Woo! And then you can look at all the 6,179 works that we have that are indexed in OpenAlex. And then you can click on to actually our institution page. You can see our ROR. Our ROR or ROR is kind of like the ORCID for institutions. So the Open University has a unique, I think it's a number or maybe a string, a unique code that is used in databases to identify everything as created by the Open University. We know that about 60% of our articles are apparently open access, so yay us. And you can again scroll through this list to see which publications were most cited or most recent, etc. Okay, so that's already pretty cool, but it gets even better. So I'm doing a project with a lot of other cool people. It's called MPAD, which is an acronym for something which I don't quite remember, but I'm sure it's a cool acronym. And it's about the definitions that people use in the literature for empathy and how they then measure it. And one of the things we'll do is probably, given what I've seen in the literature so far, show that the definitions and the way people measure it don't actually converge. So to show that, you don't need all empathy research. You just need a sample of empathy research where there is no reason to assume it's biased. And we do this project without funding, so we wanted to keep it quite lean and lightweight. So we wanted to have as few hits as possible that still allow us to say something useful about how empathy is defined and measured in the literature. So that's how we constructed this query. We only look for studies with empathy in the title, published in 2023, that are an article in the psychology field and that are open access. Because, of course, there's no reason to assume that people who have funds for open access or are more inclined to work according to open science principles somehow define empathy differently or measure empathy differently. So this open access trick is a very convenient way to make your systematic review much more efficient without, in most cases, but not all cases, introducing a risk for bias. So in this case, we have 296 results, so we can then go screen and extract. Actually, we skipped the screening in this project. It's a very cool project. I can tell you all about it later. But we extract 296 results. Now, there's a package in R called OpenAlexer, which allows you to use this to apply the same query. That looks like this. If you all memorize it, I can test you tomorrow. And then what you get back from R is basically from OpenAlexer is basically all your hits directly in R, which you can then edit further. So I have a few lines of R code, which anybody can get because they're in the public Git repository. So if you want them, let me know. That does exactly this query. That's actually where this source code came from. And then produces this spreadsheet. And the spreadsheet has all the hits of the query. And on the left-hand side, you see the title of the article, which is a hyperlink to the PDF of the article. So that means during screening or extraction or whatever, it's super efficient for people to just get the PDF. You don't have to search, it's just there, basically. What you also see here is columns C and D, the source identifier and the extractor identifier. And if you do open systematic reviews, it's very important to anticipate on what we call interoperability, basically making sure that you store stuff in a way that's understandable by computers. These source identifiers are unique identifiers for every article. And they are basically the short DOIs, the short DOIs. The short DOI service is from Crossref, the people who also make a lot of DOIs. And basically you throw in a DOI and then you get a short DOI. And a short DOI it just acts as a DOI. So it's a unique short code. And if you put it after https://doi.org/ and then the short DOI, then you always load the article as if it were a DOI. DOIs are not very wieldy. They're long, they can contain loads of characters, but short DOIs are very short and only contain letters and numbers. So that means they're super useful, unique identifiers for articles. And if you have them, you can always immediately find the article because you just go to doi.org/the short DOI. You also see the extractor identifier here, and those are the shortkits, which is a brilliant invention, which is basically the ORCID, but then converted into a very short string. So it's a unique short string for every person that can easily be converted back into an ORCID. So if you do a systematic review, you can use these to keep track of who screens what, who extracts what. And they also work for qualitative research or for quantitative research if it's important to keep track of who does what. And then it's easy to combine this information across multiple projects. So OpenAlex has an insane number of articles compared to PsycInfo or Greenfile or ERIC or other databases. They are currently at about 264 million articles from 260,000 journals or books or whatever, and they have 100 million authors. That's really quite a lot. They have a comparison in one of their spreadsheets, presentations. Web of Science is only at about 80 million. As you see at the bottom, OpenAlex, when this slide was created, was at only 236 million. So this is a bit older than the slide I just showed. Web of Science only has 82 million. Scopus only has 82 million. Google Scholar has 390 million, but that's the only source that seems to have more articles than OpenAlex. Of course, at the same time, they don't cover the same stuff. So people do studies about this kind of stuff. That's an entire field, like bibliometrics. And if you look at Diamond Open Access and Gold Open Access, you see that there are some journals that are covered by OpenAlex, but not by Web of Science. Or actually, there are a lot that are covered by OpenAlex and not by Web of Science or Scopus. But there are also some that are covered by Web of Science and not by Scopus or OpenAlex, or that are covered by Scopus and not by OpenAlex, etc. So that means that the coverage of these databases is always different. That means that if you do a systematic review, if you use the closed source databases like PsycInfo, ERIC, Medline, PubMed, etc. PubMed, by the way, is also closed source. It's owned by the American Medical Association, AMA. You can use it for free with quite a lot of restrictions, but still you can use it for free. But the data itself are not openly available, and they can stop their access at any time or change their model at any time. So that's why I included in the closed access sources. So the closed access, closed science bibliographic databases cover different journals and articles than OpenAlex, which means that if you want as much as possible, you should use them all. If you don't necessarily need to find everything, then in many cases OpenAlex can suffice, with the added benefit that your query is completely replicable by anybody, regardless of their funding. Because of course, a lot of institutions in the world don't actually have funding to get PsycInfo or Greenfile, etc. Okay, so that was the bit about systematic reviews. I also have some slides, because they used to be in the old one, about pre-registration. If you'd like, I can go through those as well, how to pre-register your systematic review. But we can also stop here and go to questions and answers. Since I'm sharing my screen, I will not go to Teams because I haven't stopped the recording yet. But Manon, maybe you can indicate whether you have any indications that people would like to move to questions, or that we should, that I go on with the pre-registration. Note that I'm still recording this, and everything we say will be put on YouTube. So.
Well, there is a question in the chat and there's a hand raised, so I'm not sure if people want to go to the discussion right now. Maybe.
Okay. Could people drop in the chat preference for, like, by typing either pre-reg or stop? And then if there are some responses, maybe we can see. Actually, I can probably just go through the pre-reg stuff in like 5 minutes, and then.
No, prereq, please. So
Okay.
continue.
No, that's good. I'll still try to do it in 5 minutes though. And then Lloyd will have to ask a little bit with this, wait a little bit with this question because I saw it pop up. So pre-registration is the practice of, before you start doing some relevant research activity, writing down your plans and publishing them publicly somewhere. You can also embargo them, but usually there's no need. You can usually just make them public. Pre-registration has a number of benefits. One of them, maybe the most obvious one, is that it really helps your planning, because it forces you to think about a lot of questions beforehand that otherwise might only come up in the later stage. And the advantage of thinking about this stuff beforehand is that you can still make other changes to make sure everything can go the way you want it to go, which you can't do later on. There are also, in the beginning, when pre-registrations became popular in psychology at least, but I guess the same will go for other related social sciences, they were mostly argued to be beneficial because of their epistemic benefits. So basically, they aid in the efficiency of knowledge production. That view is very much embedded in null hypothesis significance testing, which is one specific approach that is used if frequent statistics are used for confirmatory hypothesis testing. It's only a relatively small part of all the social science research, but it has dominated the discourse for quite a while. But now, fortunately, people are seeing more and more that there are a lot of benefits, even if you don't do confirmatory research. So also for qualitative research and for systematic reviews. One of our colleagues, Piet, recently actually got a registered report for qualitative research accepted. A registered report is like a pre-registration, but with peer feedback. So peer reviewers actually review your pre-registration, your registered report, kind of like an article with only the introduction and the methods. And then you can still revise it, so you actually get expert advice on your study before you did it. And then if it's accepted, you do the study, and then you also usually have a so-called in-principle acceptance, which means that people will accept the results, whatever the results are. But that's only for registered reports. Pre-registrations you just can do completely on your own, and they mostly help with figuring out what you want and making sure that later you will still know what to do and you don't deviate without noticing it. We started this process because I was supervising a PhD master thesis student who wanted to do his master thesis about the difference between yellow cards and red cards in soccer. And it turned out we couldn't actually pre-register this anywhere, because the pre-registration database that's usually used, Prospero, only allows you to pre-register health-related systematic reviews, and they also have to be systematic reviews, so you can't pre-register scoping reviews. Back then, Twitter/X was not yet evil, so I asked some people with expertise in this area whether they knew about other solutions to this. And James Coyne, who unfortunately passed away last year, but had a huge following, boosted this, and that kind of got the ball rolling. And I connected to Nicky van Veghel, who is a veterinarian who had the same frustration that he couldn't pre-register his systematic reviews. So then we got in touch with Brian Nosek from the Center for Open Science. Those are the guys who create the Open Science Framework. And basically we got together a group of people to work on this. So this is the whole group. It kind of grew organically. People of you who've done systematic reviews may recognize some of them because, well, these are kind of systematic review people. And Olmo was the person who actually who pulled the project, who coordinated most of the project. The idea was to create a systematic review pre-registration form that wasn't specific to any discipline, so it works for everything, and it works for all reviews. So as a result, there are no questions that you have to fill out, but also, like the other side of the coin, a lot of the questions are very relevant to some types of review or disciplines, but not to others. It's got published since. The article is actually mostly just a list of the thing, and it's been added to Open Science Framework now, and it's in this R package that I explained to you before. This R package allows you to basically create a version on your computer of the form that you can then fill out, so you can specify the questions, and then it helps you to store it. So if you fill out this pre-registration form, you start with some metadata, so the title, who works on it, stuff like that. You select the type of review. As you see, these are text fields because different disciplines call things differently. So we didn't want to impose one set of definitions from one specific discipline. You indicate which stages you distinguish and where you are at the moment, and when you plan to start and stop. And ideally, you explain to readers why you're doing this and what you actually want to achieve. Then you list your primary and secondary research questions. The distinction is usually that the primary research questions guide your design and your decisions, and the secondary research questions are kind of like low-hanging fruit that you take because you can, but you don't allow them to influence your design. And whether you have any hypotheses if you do a confirmatory study, or any expectations if you don't do a confirmatory study. Then you list the dependent studies, the main variables you're interested in. And if you are interested in association, you also list the independent variables and any additional variables you're interested in. Then you describe all the software you use and funding sources you have, as well as conflict of interest and how you want to deal with overlapping authorships. Because often if you do a systematic review, you will involve people who did a lot of research in the field. So that means you're probably going to find some articles of theirs. Of course, there are 2 points here. First, if you start looking at the rigor with which a study was conducted, they might not always score optimally, and that might not be pleasant for those co-authors. And in addition, those co-authors have a lot of background information that's just not available for other articles. So that means there's quite a risk of bias here, so you have to have a plan in advance of how to deal with this. Then you specify your search strategy. So that consists of the databases. As you see here, OpenAlex was not a thing yet when we created this. And the interfaces you use. That's a bit of a... So OpenAlex is both an interface and a database, but generally PsycInfo, for example, is made available. PsycInfo is owned by the American Psychological Association. Medline is owned by the American Medical Association, but those are made available through different interfaces. So we have, I think, EBSCO for some of them. We may have Ovid for others. So there are a number of those interfaces that you then use to search the underlying database. So you have to list both because all the interfaces work differently. Then gray literature is defined as literature that's not available in those databases. And you have to have a plan for how to deal with it. The plan can also be that you will ignore it, of course, but then at least you can make that explicit from the get-go. And your inclusion and exclusion criteria. So what kind of articles you want to find. And then for every database, the query you will use in the database. That was the text that you saw me entering into OpenAlex earlier. Then generally, you will want to validate your search procedure to make sure that you find the articles you need to find. Usually when you do a systematic review, you already have some articles that you know you want to find. So you have to have some strategy for this to make sure that you actually find them with your query. And you might have additional search strategies that were not covered by these items so far. Then, often, you won't have all the information you need in your articles. Tragically often, in fact. So generally, you have some procedure to contact the authors. And if you want to report back on what those authors told you, whether they responded, stuff like that, you can also indicate those plans here. Then if you do a query, after a year or 2 years or 5 years, of course, more studies will have appeared. So you have to have some idea of when you consider it expired and want to repeat it. And then finally, you can justify your decisions and you can add any details that were not yet mentioned. Then, once you have your hits, you start screening. Screening can have a number of stages. For example, if you have a lot of hits, you might just start with the titles first and then also look at abstracts. But you might do it in one stage. You might want to mask some authors from some screeners from some fields because, for example, screening decisions might be biased by date, year, or the journal or the authors. Which exclusion criteria you use and how you define them, and which instructions you give for how to screen and when to apply each exclusion criteria. Then, if you have multiple screeners, you can look at how reliable their process is, whether they basically make the same decisions, and you can have a procedure for how to deal with different decisions. If you don't want to include all the articles but a subset, that means you will have to have some procedure to find that subset. and some idea about how big you want that subset to be, the sample size. So you can explain that here. And then again, you can justify your procedure. You can explain how you're going to do your data management, like document all the decisions by everybody and how you're going to make it public, and any other details that won't get included. Then you start with the extraction. You list everything you want to extract and how to define them, etc. Again, which stages you use, the instructions you give to the extractors, again, potential masking of extractors if you don't want them to see certain parts of a study, reliability computation, and reconciliation procedure. Hopefully you'll recognize quite a bit from the screening. And again, the justification, your data management plans, and additional extraction details. And then for the synthesis, so the actual analysis, which data transformation you plan to conduct. Often, for example, if you look at effect sizes, you have to transform them all to one metric, to Cohen's d, for example, or Pearson correlation. How you want to deal with missing data, how you want to validate your data, so look at whether everything seems to have gone well. How you're going to look at the quality of the studies, for example, by inspecting their methods or stuff like that. And then the analyses you want to do. Finally, if you want to draw conclusions or make some kind of inference, ideally, you define your criteria, your procedure you will use to get to those conclusions in the beginning before you start actually looking at your data. So you can list those here as well. Then, just like during screening and extraction, you may want to mask the synthesists, especially when it's like a contentious topic, for example, or there's a high risk of bias in the analysis. And then if you do that, and you have multiple synthesists, again, you can look at reliability. You need to have a reconciliation procedure. And then for the analysis, you often want to look at publication bias because journals are not objective. And so introduce bias by determining what to publish, which articles to accept. So you'll want to have some plan for how to deal with that, or at least look at it as well as doing some sensitivity analyses to see how likely it is your results were influenced by small decisions you took. And then again, finally, you have the justification of your process, and then you describe how you want to manage your data and make everything public, and you end with any additional details that were not included. If you use R Markdown, you can integrate this in your regular workflow by using this prerecord package, but if you don't, you can just go to Open Science Framework and fill it out there. Okay, thank you for your attention. This concludes the bit that I will post on YouTube, so I'll now go back to OSP Studio and stop the recording.